Good morning, guys, and welcome to. Hold on. Good morning, everybody, and welcome to this session for Astronomy 120, Section 71. This is actually a late start class. Today is Monday, February 10th. We are in our second week of instruction. So I know I think I made the change on it so that people can just walk in, but apparently we still have the guest thing in here. So anyway, so people who are not attending live, I'm expecting them to watch this recording later on. So I'm going to be posting this recording later on. So for people to watch it, because it's very, very important to keep up with how this class is going to be basically administered, how this class is going to go in this semester. So we need to know the process. So that's basically the purpose of today's meeting. There will be another meeting. So initially it was planned for the 13th. I think I changed it to sometime next week when we're going to be meeting. There are two reasons for that. First of all, I have another meeting on that day on the 13th, which is this coming Thursday. And in addition to that, I actually want to give a little bit of room for you guys to get to know the process of how this class is working, so that you also can ask more questions and things like that. Besides, there will be another new types of assignments down the road. So we would want to include that in our discussion in the next meeting. So the next meeting is going to be next week. Let me double check to see the date on it. Of course, you're going to be receiving plenty of notifications on it to make sure that you know ahead of time when the meetings are going to be. So let me go back to meetings. So the next meeting is planned for February 20th. Because the 17th is a holiday, which is this coming Monday. So instead, we're meeting on the Thursday of next week. So it's going to be about, what, 10 days or so from today. And in that meeting, again, we're going to be discussing some of the items related to new assignments and things of this nature. Okay. So, and that meeting is going to happen at noon, so that you know. And you will receive ample notifications. I think you may have received by mistake a notification about it sometime on the weekend. Anyway, so this is basically how we're, at least in terms of our meetings. Any questions so far before I jump into the course on how it's structured and so on and so forth? Okay, no problem. I know some of you are actually sitting in my other astronomy class, namely the Astronomy 125, which is the lab version, either section 1 that meets on Tuesdays or section 2 that meets on Wednesdays. So that's a different class, by the way. That's those questions related to that class, which is the lab version of this class, are completely not connected to this one. So this one is actually the lecture version of that, and the other one is the lab. And this one is actually prerequisite for the lab. So you can't take the lab unless you either have taken 120 or you're taking it concurrently, but the other way around is different. Anyway, so let me share with you the screen so that you have an idea of how this class looks like from your vantage point. Share. I need at least one person or so to confirm that you guys are looking at the screen with that says Astronomy 120, Section 71 on it. Just to make sure that.
I see it.
Okay, thank you very much, Eric. Anyway, so in this is basically how it looks like to you when you come into class. Obviously, when you land, you don't land on this page. You land on this page instead, which gives you an overview of how this class is structured. Two key things that you notice, and several key things actually that you notice in here. On the left-hand side in here, to do, usually is the stuff that you have to do, and these are sometimes a good indication to start looking for things, especially if you're in a hurry or something, which we're going to come to it. So how you're going to organize your time. It was very important that you have to do a schedule for yourself, because if you're not working with schedule, this class is probably not for you. You really need to plan it right. Okay, so the course, the way it's outlined is you have the models, which is really where we're supposed to be working on a regular basis instead of this right pane. So that's the wrong way of going about it, unless you really, like I said, you're in a hurry and you have to do something. That's probably you can glance in there and see what's going on. But this is where we're supposed to be on a regular basis. One of the things that we have also is the syllabus of the class, which I'm going to glance through it. I know that you received about a week before class starts the PDF version of this syllabus, and it's the same thing basically. We're going to go through it briefly, and this is a link actually for the online version. And there is another thing in here, which is an open topic discussion item, just in case, for example, you have a general question or a specific question related to something that does not have its own topic of discussion or something like that, and you want to ask question. It's a good idea to start doing that because of the fact that sometimes it may be answered faster by another peer of yours than me. And number one, number two, even if I probably sometimes try to explain it, it may be probably better that that one of you guys can jump in there and help out, because sometimes there is a different perspective and different view on things that sometimes can be very useful. And also, if you're not asking a question, it's a good idea to browse from time to time in there to see if somebody is asking a question and you have a different take on it. You know, I may have explained it, but it's a good idea to go through it and probably rephrase it and at least to enrich the topic. One thing. The other thing also, sometimes when you try to explain something or you try to tell something, it sticks better than if you just basically listen to somebody else explaining it or read someone else explaining it. Sometimes it helps a lot. It helps you more than the other recipient person to try to talk about the topic. So that's the general discussion item. Let me go through the syllabus because that's basically a very important aspect of it. The way we access stuff in here also is we have this left pane. It gives us announcements, models, and also grades. For this, I'm logged in as a student, by the way, so that you know you can see it in the bottom student view. To see it how you're going to see it yourself. So some of the things don't work under this student view because of the fact that this student does not have an account on College, so just the basically like staging account for us to test stuff with. So one of the things that we're going to go to is the syllabus, as I said, in here you have the link in here or there, so it doesn't matter. So we're going to go through it quickly, and that has to do with the office hours, okay? Of course, you have my contact information in here. This is the office number that I have in here. And this is my email address and all of the other. I think somewhere in the syllabus somewhere, you probably can find my personal Google number, which is here, that you can send me a message to just in case if something does not go through or something like that when you're trying to reach me. Anyway, so this is the syllabus. These are my office hours. One of them is actually today, which is at 9:30, since I don't have anybody else scheduled. So I have you guys in here for this meeting. Also on Wednesday, I have in the evening, after the lab for Astronomy 125, I have an office hour, and that is actually online. So if in case you're not on campus, you can still meet online if you want to. I also meet on Tuesday, Thursday at 8 o'clock in here in my office. So if in case you happen to be on campus, I'm available during those times. The only thing I am asking really is that you send me a message ahead of time so that at least to make sure, first of all, I'm in my office because the campus is very large and sometimes I go to different areas on campus. So I could go to the STEM center, it could be somewhere in here. So it's a good idea to send me a message ahead of time to let me know that you're coming, number one. Number two, also try to give me a heads up telling me that, for example, I have a question about this homework, or I have a question about that lesson, or I have a question about this assignment or something, to give me some sort of a reference to know exactly what or you have a question about your grade or something like that, to give me some sort of a heads up. Now, if none of these times works for you, including the online time. Okay, that's fine because you happen to be working and that's why you're taking the class online, or you happen to be taking classes somewhere else and that's why you're taking the class online. So none of these things that you announce work for me. So what can I do? Am I out of luck? No, just reach out to me. Okay, we can still meet in other times. Most Fridays I'm actually free. I mean, some Fridays I have division meetings or department meetings or other things related to college activities. But honestly, most of my Fridays are free, except down the road. I'm looking for April, toward the end of April and May, where I will be involved with another activity in here on campus with the STEM students. But I will be on campus anyway, so I'll be more than happy to meet during those times, whether early in the morning or the afternoon or something like that. So even during those times, so there is no reason why not to meet during any other times. Uh, Thursday afternoon, whatever other times that might work for you. Even on the weekends, I usually like not to meet on Saturdays because I have other stuff to do, personal things. But if we have to, we can meet also, whether Saturday morning, afternoon, or even Sunday. So, in other words, don't read this times as being written in stone. No, they're not. Okay, I'm very very flexible. The only thing is I cannot meet with you if I'm teaching and I have a lot of classes to teach on campus. So during those times I can't meet with you, but any other times I'll be more than happy to meet with you. And that's also another reason why you really have to send me a message ahead of time, because sometimes other people also have already requested time to meet. So you come in here and you stay for probably an extended period of time waiting and you waste your time and you're not going to be receiving the attention you deserve. Therefore, it's a good idea to send a message ahead of time to let me know that you're coming, and furthermore, to let me know what's the topic you want to discuss. And try to be as specific as you can, not just stating your name, but your name and also the section you are in, because I have two sections of Astronomy 120, and I have two sections of Astronomy 125, and I actually have two physics classes too. So just stating that your name is John or Mary and you have a problem with homework 3 is kind of vague for me, and it's not going to narrow it enough for me to see exactly what you need, in other words, to help you specifically with your needs, instead of having to waste a lot of time trying to figure out exactly what's going on. So please send me messages ahead of time, okay, that you're coming. And okay, there was an earthquake. I don't know if you guys felt it or not. Did you guys feel the earthquake? Any one of you?
I did. My
Can
kitchen
you?
was moving.
Yeah, here too. Wow. Okay. So is Eric too. Okay. So that's Southern California for you guys. Anyway, I'm gonna go on our recording in here. Anyway, so please send me a message ahead of time and send me as specific as you can be in the message that you're coming to meet, whether during these times or any other times. Okay. At times, this class can be difficult and hard to do. Okay. The last thing I want you to do is be stuck at some point. I don't want you to be stuck even for 5 minutes. When you see yourself spending more than necessary time and stuff on things, please send me a message, okay? And we're going to talk about the level of difficulty and how much work is required for this class too. Okay. The preferred way for you guys to send me messages is through the inbox, honestly, because that answers half of the questions already. It tells me your name, your section, and the class you're calling from. You're sending me the message from. So it's zeroing already on a lot of things for me. Okay? Instead of sending me an email or calling me and leaving a message that is kind of vague. So that is really my preferred way of communication. So that's how I like to communicate. And if in case you communicate in other means, I would like to bring the conversation back to here, because it helps me basically get things organized when I see everything is in there, everything in that place and everything concise, so that I can communicate to the rest of the class and everything else. And of course, it's self-contained. It's much easier for me to look for it, and it's also much easier for you to look for things to find them. So again, this is the preferred way of communicating with me, and I hope that you guys take that into account, so that when you're trying to reach out, this is the preferred way of sending messages, with requests for meetings, the requests related to grades and things like that, okay? So that you know, I don't communicate grades over the phone, never, okay? I will not communicate the grades via email. So if you send me an email requesting what's your grade or what's the status of such and such, I'm not going to respond to that. I'm going to respond, but not to give you specifics in a sense that I will refer back to Canvas. Because when you come to Canvas, you should see everything that you are related to your class. You have difficulty connecting to Canvas, again, you really need to reach out for help. And if I can't help you, I will direct you to the place where they're going to help you with your accessing your materials. Okay. So this is in general. Hopefully, you guys have that. I mean, the rest of the stuff related to the class is just typical syllabi. One of the things that I ask you guys to do, if you can, is this software, which is really simulates for us a lot of the things that we do uh, uh, basically in course. So it's Stellarium is actually used by companies nowadays for planetariums. And if you're taking my class of the Astronomy 125, which is the lab version of this class, you will see that we use this software a lot to track the motion of the moon, the sun, and different objects in in the sky, okay, whether in the solar system or outside of the solar system. And it's a free software, so it's not something you're going to pay for. Uh, Also, how the course is outlined. You will have at least one project in here. And that's one of the purpose of the next meeting that we're going to be meeting on the 20th to discuss that. You will have homework assignments, and at times they will be, like I said, requiring some work, okay? And you will have 3 midterms in this class. And the participation also you're graded on it in terms of engaging with your peers on different assignments. One of them already you have seen it, and some of you already have submitted that part of that assignment, okay, namely the discussion item related to the Earth being flat or not. It's just an introductory topic so that you can get to know people and people get to know you and introduce yourself and also be introduced to the process of how we do discussions. So, and that's basically how this class is. Other than that, this is typical things, okay, on how things are done. So, let me go back home. There are two ways of accessing the materials in here, either from the home page or from here. Doesn't matter, it's the same link. So, and this is the content, okay? Right now, as I said, I am in actually the student view mode. And the student view mode at this point is just showing me 2 weeks because week 1 was last week. And this is this week, okay? And next week you will have, by Sunday, you should have another section in here that opens up for week 3 and so on and so forth, okay? At some times, we're gonna have a little bit more work than usual and so on and so forth, okay? So, the structure of these modules, where you're supposed to go from top to bottom, not as I said from the to-do. Do not go by the to-do, okay? That is the wrong way of approaching online classes. Okay, every module will have an objectives. This one is special because it introduces the rules for this class. So I'm hoping that you guys go through that and understand what these rules are. And once you agree with them, you mark as done. So if I mark as done, now I'm ready to go next, okay? To the next one, which is the objectives for this class. Again, objectives gives me stuff related to this class, okay? The assignments and when they're due. So if I click on this assignment, it gives me the assignment related to this discussion item. And of course, it tells me also how it's graded. So it's very important for me before actually reading the assignment or going through the assignment to actually first of all go through how am I going to grade to be graded. I really want to get 5 points and 5 points and 5 points for a total of 15 points. So what should I do to get 5 points on all of these sections? I need to do this and this and this, okay? So I have to read this in here and make sure I meet that, okay? So let's say, for example, I read and I only saw this is what I have done. But technically, I could grade myself, okay? I don't need an instructor to grade me. If I am honest with myself, I could just see, okay, I got 3 in here. I got 4 in here, and I got 5 in here. That's 5 plus 3 plus 4, what? That's 12 out of 15. Okay, so that's my grade. So the thing with it is that there is a rubric for most of assignments, if not all of the assignments, they have rubrics. So that's what I really want you to pay attention to. Then I can go now here and read what the assignment is asking. As a matter of fact, it says to click on this page to load for the next, okay? I don't know if this student can do it or not, okay, because it's a test student, so let me do it, okay? Okay, it opened the assignment, okay? And it's telling me to get started, so it's showing me tricks on how to do this. So hopefully you guys, are you looking at this get started? Anybody? Gareth?
Yes, I'm looking at it.
Very good. Thank you. So at least it gives you an idea of how to do this discussion. So hopefully you guys go through it and you submit your assignments in here and so on and so forth. Actually, I see some people already started that, okay? So you can go through the assignment and pick up the topic. So there is a PDF file that I need to open, pick up a topic, and basically answer all the prompts. So let me go back in here to where we were. So this is a typical assignment. So let me go back to where we were in the models. We were in the objective, actually. Okay, so let me go back to the models, module 1. So this is typical assignments in here. There is a discussion also, which is actually a similar discussion, except this one is worth 5 points. This is due February 15th. This is due February 17th. And there is a content in here. So every week we'll have similar stuff in here. There will be a discussion. This week especially, it has this rules and it has also this extra assignment. There is a discussion item. And again, there is a content. And here, this is not to substitute what you need to do, which is you need access to the book and reread, you need to read the unit. This is a summary, okay? This is not a replacement of what you need to do. And I'm going to talk about what you need to do so that we have a clear understanding on that. So this is just a summary. And these are 2 PowerPoints in here. First one is Unit 5 and Unit 6, okay? So what this is telling me is, this is a PowerPoint. This is not, again, the whole thing. So if I click on it, it's just going to give me a PowerPoint. So if we were in a class, I'm going to probably go through some of these points in the PowerPoint, but I'm going to go more in depth about these items in here. So again, this is not a replacement for what you really need to do. It just gives you some sort of a reference, okay? So, and there are 2 units for this week, units 5 and 6. So I need to look at the book, honestly, and look what these units 5 and 6 are. Unfortunately, my book now, I landed to another faculty who's teaching the same class in here because they opened up 2 new sections, actually, because apparently it's a popular class on campus. So he has the book. So if you get the book, you will see that the book is not divided into chapters, but rather into units. So chapter, so that you know, it's really, usually it's divided into different sections, and each section is a big section, and then the whole chapter is so many pages, sometimes 30 pages, 40 pages chapter. But instead, you have about 6 pages each unit. It's like sections of a chapter, okay? So instead of chapters, you're reading sections, 6 pages. I mean, 6 pages, normal probably person can read them usually in about maybe 20 minutes at most if they're taking their sweet time. And usually it's a lot less than that. It's about 5 minutes. I mean, if you really want to go, it's and some of the things are repeating. Now, you have 2 sections in here, 2 units, I'm sorry. So you're looking for a total of about 12 pages in here, 10 to 12 pages. So I need to read the book, okay? Because if we're meeting on person, if this was not an online class, you're looking at an hour and a half twice a week. So that's 3 hours minimum of coming to campus, plus wasting time driving or getting into the bus and getting in here, finding a parking spot. So that's really more than an hour and a half. I mean, if you count it, I mean, depending on how far you live from here, it's going to be a lot of time. I mean, in here. So you really need to spend at least an hour and a half times 2. Ideally, you should really spend an hour and a half and an hour and a half. But if you can, you need to spend at least those 3 hours going through the materials, going through reading the materials, reading those 2 units, in this case, 2 units. Next week, I mean, the week after, You see, 3 units. So depending on the amount of work that needs to be done, we could be looking at sometimes actually 5 units, sometimes 1 unit. So depending on the amount of work, we're adjusting it, depending on how much homework we have, depending on how much exams we have, depending on how much stuff we have to do, that number changes, fluctuates. Again, remember, this is less than a chapter. So between this 2 weeks, it's probably about a chapter, okay? So that's so that you know. So every week, if I'm taking an online class, I really need to make sure that I'm spending a minimum of 3 hours. That is just for going through the content by itself. Because that's what you would do if you come to campus. If I don't do that, I'm not really learning. If I don't do an hour, the equivalent of 3 hours a week on an online class, which is similar to what I would have done if I go and take the class in person, then I'm not really learning. I'm kind of cheating myself. I'm calling it learning, but I'm not. Okay. So that is one thing. But if you come to campus and you take a class, it doesn't matter which, you're going to have homework and at-home assignments. You need to go home and do some topics having related to problems with that class, having to do extra stuff related to that class. Usually, you find yourself spending between an hour of a minimum hour to 2 hours at least in addition. So to be frank, this class requires about 4 to 5 hours a week of work between reading the content, watching the things in here that I'm going to talk about in here, and hopefully getting the content sink in so that you're going to learn it and practicing it. If you find yourself not spending that much time on this class, you are really not helping yourself. You're really, because this is actually on your own pace. Sometimes, for example, you're working, I know you're working, you're taking other classes, and you can do it on Monday because you have full schedule on Monday, or you can do it on Tuesday because you have full schedule on Tuesday. But you need to allocate time, preferably during the week, just like to make sure that you put yourself to it. And the other thing also is that, you know what, you put a schedule to yourself. You say to yourself, okay, from this time to that time, it's dedicated to my Astronomy 120 class. I'm not saying this is the case for you, but let's say, for example, every Wednesday, I don't know, from 10 a.m. to 11:30 in the morning, or from 9 a.m. to 10:30 in the morning, that's an hour and a half, or if I can find another time for the other session, from 8 in the morning till 11. Let's say, for example, this is the time I have allocated for my class, or on a Friday afternoon. Or now I can't do that because I have so much schedule during weekdays, then it has to be Saturday or Sunday. One of them, you have to dedicate that much time. If you find yourself you can do that, honestly, you are not doing what you need to do to pass the class the way that it ought to be. That is how we're discussing it. You're saving a lot of time going to driving and getting into campus and finding a parking and wasting all of that time. You're saving a lot of time basically having, I mean, yes, you can be walking at home in your comfortable shoes and comfortable clothes and going through the content, but that's actually a plus, okay? But you have to dedicate that time. Let's say, for example, you allocate 3 hours and you find yourself spent an hour and you think that you're done. Please don't give up on that. Okay, try to go through the content because there is far more to it than that. Okay. So there is that assignments and things like that. So that's what I'm saying in this class in here. You really have to think in terms of how it compares to a class on campus. And if you find yourself not doing that, you're not doing the time it's supposed to be doing. Which brings me to this item in here, which is the recordings from each week. If you look at this recording in here, let me start just to see the time. I'm not going to play it. Okay, it says an hour and 19 minutes. Okay, that's an actual me from a few years back from 2022 going through this same stuff, this same content. So that's an hour and 22 minutes. Okay, let me click on this one in here to see that's 56 minutes. okay? So that's a total of 2 hours. Obviously, with nowadays distractions, with nowadays YouTube and Facebook and all kinds of online things, distractions, sitting for 2 hours and trying to do things is hard, okay? Watching at least videos. Reading a book is fine. I can do that. I can spend a lot of time reading. I have no problem with it. But watching something online for that much time is hard. So the way I recommend that you do is try to pick up the topic and break it down into each items. Usually it's about 10, 15 minutes. Okay. So an hour and 20 minutes divided by 15 minutes, that's going to be about what? 4, 6, 7, 8 times probably of break. So you can do that. Okay. 20 minutes at a time at most, but you can finish the whole content in here. So in lieu of sitting in a classroom, this is one option that you could do too. So the resources that you have before you are the following: the book, which you must have, and these videos from previous classes that I taught in here, and the PowerPoints, and that summary. Now, if none of this is helpful, please reach out, send me a message saying I still don't understand, for example, how the idea of a right ascension and declination and compares to, for example, to, I don't know, the longitude and the latitude on Earth. How are they connected in here? I watched the YouTube, I watched the videos, I read the book. I still have kind of a question in here. For example, how do we start uh, 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 the time because the earth is spinning? How do we start that right ascension thing? Questions like that, okay? So some of these things probably you might be asking them and how to locate objects in the sky. Yes, we're talking about it in here, and that's what the units are explaining, but I still don't see it. Can we sit down? Can you give me an example, for example, that I can understand? Maybe you can discuss it and maybe we can come up with an understanding and hopefully we come up with a picture that can be helpful. And at the end, you move on. Okay. So that's the whole point in here that I want to bring out to your attention, that every week you will have these essential components: an objective, a discussion, content, PowerPoints, and some videos related to that week. This is how week 2 looks like too. Week 2 has objectives, content, discussion, 3 units actually. It has those videos, except now it has a quiz actually, okay, too. So from time to time, this starts to pop up things that need to be done. I know I am not showing that in here. Down the road, you will have homework assignments. You will have also midterms, and you will have a project. So we have, that's are the different types of activities. So where is that my participation? The participation is coming mainly from this discussion items, okay? Getting fully engaged with them and getting your credits for them. They're worth 5 points, but they accumulate. Remember, they represent 10% of your grade. Unless you're planning to get a B in class, you really want to make sure you do those too, because that way you bring up your grade to an A. Otherwise, you're working off of a 90% or less. You don't want that. You want higher, more than 90%. You want to get an A in the class. So you would want to do that. You would want to do your reading, and you would want to do all of the assignments. The quizzes is another thing, which brings me to another point I did not mention when I was going through the syllabus. If you are an SAS student, please send me your request as soon as possible to be accommodated, to make sure that you're not you're treated fairly. Okay, if you're not, then it's fine. You should be okay. You should have everything you need in here in terms of your stuff. Okay, just an FYI, this week's session will have a blank video in it, and the other two. And that blank video is related to this very same session that we have in here. Once we're done, I'm going to post that link in here so that you have access to the content that we're discussing today, so that we will have it in here. So this is a live session of Monday, February 10th, which is today. So this is in a nutshell how the course is structured. This is the expectations of things like that. So now I mentioned something about the level of difficulty, and I really want to make sure that you guys are aware of what's going on. Do we really need to know a lot of math to take this class? Do we really need to know a lot of physics to take this class? Because after all, this is an astronomy class. How much content do I really need to go and get all of those algebra things to get them to know? Okay, here is the thing. Everything is self-contained. You have difficulty doing any of this math things, please reach out, number one. Number two, all of this homework assignments, I have done them with other students in the past, and I have a YouTube channel where it goes in detail on how to discuss these things and how to work out those problems, okay? You go through those helpful tips from the YouTube channel. You go through the helpful tips in here, and you still have a question, for example. Well, it's asking me, for example, to find the distance from the homework is asking me to find the distance to the galaxy Andromeda based on the angular size of the galaxy. How am I going to do that? Yes, you explained that there is some ratio in here, but can we go through it? Can you give me an example through it, how to do it? And so that I can understand on how to find, for example, the size of Jupiter based on its distance or something like that, because some of these homeworks have to do with that. Or for example, this homework is asking me about the retrograde motion of what you call it, the day and night in Venus, and how is that affects the alignment of Venus with the Earth, okay, and how much it goes around the sun and so on and so forth. Because some of the homework assignments are asking that. You're asking me, for example, to use the Mayan method for predicting the next lunar eclipse, for example. And I see, for example, in the example you discuss it and you make a prediction that's going to happen sometime in the year 2045, but I still don't see how you did this ratio and how you subtracted and added that number to find it, because that's the kind of math that you're expected to know in this class. I'll be more than happy to discuss that with you. The purpose is not to challenge you. The purpose is not to see if you know math or not. That's not what we're here for. Okay? I want you to understand what the Mayan method is, how it was used to make prediction to predict the. That's really the whole concept behind it. Okay, that's what I want you to understand. What I want you to see is that if you go out, for example, and you take a quarter, for example, and you move it around your eye back and forth, for example, to cover just uh, 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 Jupiter, for example, and measure that distance to your eye from where the quarter is and the size of the quarter, you can have, based on geometry, you can have a sense of how big Jupiter is if I know the distance to it, or I can find the distance if I know what the size of Jupiter is. For one assumption, I can say, for example, how about if Jupiter is the same size of the Earth? Now I know it's not correct. I know Jupiter is much larger. It's about 10 times bigger. But what if it's the same size? How far it's going to be? So I can find the number. Okay, that number is not going to be far off. I mean, it's going to be probably an order of magnitude far, but at least it gives me a sense of how far Jupiter is just by using this trick in here. Okay, and that's what the ancients used. That's what I want you to get from this class, is to have a sense of how things are done. Okay, and how concepts evolve and how things we come up with them in of course we refine the methods at the end and we come for much better methods, but the point being in here is you take from this class is the scientific method and how it's used, and if somebody is arguing with you about the earth being flat, you can present solid arguments based on your experience and what you know and how you can present it in a fashion that can refute that. I know a lot of you are not going to be majoring in science. A lot of you are not going to be physicists or astrophysicists. But at least what I want you to take from it is you appreciate at least the technique and the methods that are used so that you yourself will be confident when somebody approaches you and tell you something that is a fact in science, or at least you can confidently refute anything that does make sense, that kind of a nonsense stuff. Okay? So that's really what I want you to take away from. In addition, of course, a lot of concepts that will be discussed in detail of whether we're talking about the solar system in here. First of all, this class is divided into 3 sections so that you know. Let me stop the sharing. There are 3 different steps that we're going to go through in this class. The first one is techniques used by astronomers. The first one is related to geometry, and that's what has to do with the locating objects in the sky and things like that. The second technique, because geometry is really limited to only objects nearby. I mean, for example, if you and I will go out and look at the sky, for example, tonight, and we were able to see, doesn't matter what else, the easiest one, which is Venus, okay, the brightest object in the sky when the sky is dark and there is no moon. So if we see Venus and wait for about 5 minutes, nothing happens. I mean, practically Venus is the same. If it's, for example, a certain branch of the tree where the tree is in, where Venus is just on that side, nothing is going to happen. 5 minutes, 10 minutes, 15 minutes. An hour, maybe we will notice something has moved for about 15 degrees, so that you know this is 0 degrees, this is 90 degrees. Between them is 45 degrees. What I am saying is 15 degrees. It's hardly anything. And that's 1 hour. Okay. And if we hang around for an hour, for 2 hours, yes, we're going to see that Venus has moved to a different side of the tree. Okay. So that we can notice this thing. And this is the closest object to us, Venus. If we're trying to track Mars, it's even harder. I mean, it's going to be the same degrees, but it's further away. And the same thing with any other objects, as a matter of fact, in the sky. So using geometry is limited, honestly. So we really need to come up with different techniques. And that's where the second part of it also is useful in trying to learn the properties of light and how light scatters and how light breaks down into different components and how that tells me about its the structure of the object and something like that. I mean by it something called spectrometry, okay? Or spectroscopy, okay? So we're going to learn about that. That's part of the stuff that is used by astronomers. We're going to learn also about the Kepler's laws, which are useful for me. If I track an object and see it moving, that tells me a lot about how far it is from the central location where it's moving from. So that's Kepler's laws, Newton's version of that. So that helps me, in a sense, build a lot of tools to start learning about things. Then we'll go through the solar system. That's part two. The solar system, we're going to explore it in all of its planets, whether the inner planets or the outer planets. We're going to go in detail about some of these objects. Of course, we take the Earth as a good example, and then we move to Venus. I chose Venus instead of Mars because of a very important connection, and that is how Earth is connected to Venus in terms of size and in terms of similarities. Mars is actually a very, very interesting topic, but because we're limited in this class on how much we can do, we really can't take every single object and study it and spend about a week or so on it. Then we go into the outer planets, namely the gas giants, Jupiter, Saturn, and then Uranus and Neptune. And after that, we go into a very important class of planets in the solar system, namely dwarf planets. Pluto, Eris, Makemake, all of Sedna, and all of this, we lump them together and we try to understand them. That's actually a very important component of the solar system too. And then, of course, the Kuiper Belt, before that, the asteroid belt, the Kuiper belt, and also the Oort cloud. And then we study also the comets in the solar system and the moons in the solar system. Of course, we take our moon as an example, and that's an odd thing, honestly, when you think about it, because all of the inner planets don't have moons, with the exception of Mars that seem to have two captured asteroids, and Earth that seem to have a moon, and not just any moon. It's actually a very large moon, so that's kind of an odd thing. And also the moons of the outer planets, which are plenty of them. Any planet has so many moons, okay, from the outer planets. Of course, the Galilean system is a very important system, namely the moons of Jupiter. And those are actually, some of them are bigger than planet Mercury itself. So they are interesting objects also in the solar system. That's the different, that's the second part of the class of yours. The third part has to do with the stars. Of course, the obvious star that we start with is the sun. And that helps us actually to learn about other stars. Sun is just an average star if you think about it in terms of class. It's class G star, okay? That are stars that are much, much bigger, much, much hotter and gigantic in compared to the sun. and that there are stars that are extremely small compared to the sun. And we will see how we classify the stars, and we will see how they evolve depending on their size. If the star is small like our sun, it's not going to have it's going to really end up in a dwarf, white dwarf, basically evolve, going to shed of its outer layers when it runs out of hydrogen in its core. So it drops below a certain fraction, and then there will be normal nuclear reactions to sustain to sustain it. At that point, the outer layers go away, and then the inner one will drift into a white dwarf. The big stars, though, that are above a certain limit, they can go into a supernova, which end up in one of two scenarios. If they're not too massive, they could be in neutron stars. And neutron stars by themselves are a different beast. I mean, they come up with all kinds of varieties. So we're going to go through that, okay? So they go with some of them that have ridiculous amounts of magnetic field called magnetars, and they are actually different beasts by themselves. They are actually something you don't want to be near them at all. And if that's not weird and strange, there is actually more weirder than that, and that is a black hole. Black holes, which is another end up one of the scenarios where stars can evolve to. Okay, we're gonna discuss briefly the two types of black holes. There is the normal black holes that come up from this process, and there is the supermassive black holes that somehow sitting in the center of galaxies. And their origins of those are kind of a mystery at this point. That is, people are trying to understand where they came from, because if you think that regular black holes somehow can merge, and they do, and we have observed that in 2017 with the LIGO project. So massive black holes, they can clump together and become bigger and bigger and bigger, but there is not enough time during the universe when it created for them to explain this size of these supermassive black holes. So we're going to get that. And that is actually the end of stars. Then the cluster of stars, they come together in some sort of a clusters, and the clusters and the groups of clusters and the stars themselves, they group themselves into galaxies. We're going to study how galaxies evolve, how the galaxies work, and how galaxies interact with one another, and how they devour each other, basically. And our galaxies have devoured several galaxies in the past, in the process of doing so as we speak. And how galaxies merge when they're of similar size, like what's going to happen between our galaxy and Andromeda in the future. And also how the whole universe evolved. And we're going to ask the big question. First of all, is there life outside of this, of Earth? And of course, there is no reason why it should not. As a matter of fact, we think that life exists even in the solar system as we speak, and other planets. And also it should exist in the intelligent form. That's really what the question is. Is there intelligent life outside of the Earth? And there, again, there is no reason why it should not. And that's going to really be the whole universe, which is the group of cluster of galaxies put together, and where we are in this whole big picture. Okay. So that's basically what the course is, divided into three sections. First of all, methods and techniques used by astronomers, astrophysicists to learn about the universe. Second, the solar system, and namely everything but the sun, and then the stars and the galaxies and the cosmos as a whole. So that's really what this whole class is all about. It's a big topic. I know you probably are taking other classes, I don't know, probably English and math, and probably you're taking something else, psychology or something else. Those are interesting topics too. But think of something that studies everything in the universe, from the inert matter in it, the biology in it, the smart part of it, the intelligence in it, all lumped together in one big topic. That's this class, okay? It's a very, very big topic, and hopefully you will enjoy it as I am enjoying it. I'm always enjoying discussing these things. And if you have any questions, please reach out. I really want you guys to learn. That's the thing. And I'm more important than that, also to be able to really enjoy the topic and actually enjoy going and evolving through it too, and progressing in it. Sounds good?
Yes,
Okay.
sounds good.
Okay. Do you guys have any question for me? I know the whole point of this discussion is just so that we can get started with the class. You have any questions related to anything this class?
I do not have any questions at the moment.
Thank you, Harith. How about you
Thank
guys?
you.
The other two in here? Anyone?
I don't either.
Okay, thank you. Okay, so what I'm going to do is I'm going to end the recording and hang around for a minute or two for you guys. Thank you, Eric. And if you guys have any questions, you don't want it to go on recording, that will be fine too. Thank you. Where is the recording though? Okay. Okay, here it is. Thank you guys.